All right, we are doing lesson 17 today, and really today's lesson 17 and tomorrow lesson 18 are about something called an asymptote. An asymptote, as it says here in the lesson notes, is a line that gets infinitely close to a function's graph, but does not actually meet the graph. So it's a straight line that gets infinitely close, but never actually crosses. And today we're going to talk about a vertical asymptote. So that would be a line that goes up and down. Tomorrow we're going to talk about horizontal asymptotes. So these have to do with rational functions. Remember, rational functions are functions that have fractions, polynomials, either in the numerator, the denominator, or both. So to find a vertical asymptote, we're going to set the denominator equal to 0 and solve for x. The vertical asymptote will be at the vertical lines at those points. So to show you what I mean, let's look at the examples here. Okay, so let's look at number 1. F of x equals 6 over x plus 4. So the first thing we're going to do is we're going to set the denominator equal to 0. So I'm going to set x plus 4 equal to 0, and I'm going to solve for x. All right, so this is fairly easy. I'm going to subtract 4 from both sides. X is going to equal -4. Okay, so what that tells me is that the vertical asymptote for this function is going to be at the line x equals -4. Now, to show you what that means, let's actually look at the graph of this first function here. So here is the graph of 6 over x plus 4. And if I were, you can see it's got two parts. It's got up here, and it's got a part down here. Now, if I were to, in a second line here, actually graph my answer, which was x equals -4, okay, now it's a green line. Now notice it doesn't look like much, but notice as I zoom out, that green line gets really close to the red graph up here and the red graph down here, but it never, as much as I zoom out, it will never actually cross to the other side, of that green vertical line. Okay, that green vertical line is known as the asymptote. It's getting infinitely close to that to that red graph, but never actually crosses the red graph. And it's a vertical asymptote because the line itself is vertical in nature. For number 2, we're going to do the same thing. The denominator in this case is 2x minus 2. And we're going to set that equal to 0. All right, so I'm going to solve this by first I'm going to add 2 to both sides. Okay, so 2x equals 0 plus 2. I'm going to divide both sides by 2. And I'm going to get x equals 2 divided by 2, which is 1. So my vertical asymptote for number 2 is x equals 1. And if I look at the graph of number 2, again, I graphed 3 over 2x minus 2. And again, it has that same general shape. It's got a top part up here and a bottom part down here. And if I graph the answer I got of x equals 1, I get the same thing. It's a vertical line. This time it's a blue line. And if I zoom out, notice it gets really, really close. It almost looks like they're the same line, but they're not the same. Obviously, we know that. But it gets really close, but never actually crosses to the other side of that red curved graph. So again, these are known as vertical asymptotes. Your cooldown today will be a couple of examples just like this, just different numbers. And tomorrow, like I said, for lesson 18, we will do the same thing except horizontal asymptotes instead of vertical asymptotes.